Welcome back, guys, to our new lesson, which is called Momentum. Pause the video and scan the QR code and turn back to me. What is the meaning of momentum, guys? Momentum is the measure of how hard to stop a moving object. Let's say that we have two objects. One of them is moving by 30 meters per second, and the other one is moving by 60 meters per second. Both of them have the same mass. The first has a mass of 3 kilograms, and the second also has mass of 3 kilograms. Which one is harder to stop? It's hard to stop the object which is moving by higher speed. So the momentum P has a direct relation with the object velocity. As the object velocity increases, the momentum also increases. If we have two different objects moving by the same speed, the first is moving by 10 meters per second, and the other one is moving by 10 meters per second. But they are different in mass. Let's say the first one has a mass of 3 kilograms, and the second one has a mass of 100 kilograms. Now, which one is harder to stop? Of course, the one with higher mass. So, the momentum also depends on the object mass. The momentum is a physical term which is depending on velocity and mass. So, we can write the relation as B equal M multiplied by V. Momentum is equal to the object mass multiplied by its velocity. As we said before, the momentum is measured how hard to stop a moving object. As the mass increases, as the mass of the object increases, it's hard to stop the moving object. If its velocity increases, also it's hard to stop the moving object. Let's find the unit, the measuring unit of momentum. M is a mass which is measured in kilogram, while velocity is a velocity measured in, V is velocity measured in meter per second. So, M is measured in kilogram, V is measured in meter per second. So, the measuring unit of momentum is kilogram meter per second. So, the relation of momentum is P equal M times V. As we said, P is the momentum, M is the object mass, V is the object velocity. What is the meaning of impulse momentum, guys? Impulse momentum means the change in momentum. The change in momentum. So, the impulse momentum, the impulse on an object is the product of the average force on an object and the time interval over which acts. How did we find this relation, guys? Let's find the relation between momentum and force. Using Newton's second law, we said that force is equal to mass times acceleration. The mass is measured in kilogram, well done, while acceleration is measured by meter per second squared. So the measuring unit of force instead of Newton, we can use kilogram meter per second squared. And as we said, momentum is the result of multiplying mass by velocity. Mass is measured in kilogram, while velocity is measured in meter per second. So the difference between force and momentum is time, only one unit of time. We can write the unit of force as kilogram meter per second divided by second. Kilogram meter per second is the momentum, while the change in momentum, while the time is change. S is a change in time. So the force is the change in momentum by time. Or we can write it delta P, which represents the impulse momentum, is equal to the force applied to change or to stop the object during a certain time t. So guys, as we said, impulse means change in momentum. Delta B. B final minus B initial. B is equal M times V. kilogram meter per second, while F is equal M times A, kilogram meter per second square. So by the end, change in momentum is equal to the force multiplied by change in time. Change in momentum is the impulse momentum. Let's solve this problem, guys. Find the momentum of a car that is moving by speed of 30 km per hour as it has a mass of 100 kg. First of all, find the givens. Find the momentum. So the momentum is the mass part and the required part. Is moving by a speed of 30 km per hour. So the speed V is equal to 30 km per hour. And the mass M is equal to 100 kg. The rule of momentum, P equal M multiplied by V. M is equal to 36 km per hour, while V is equal to 100 kg. By solving this problem by this way, you're going to do a mistake because kilometer per hour is not matched with kilogram. The SI unit for velocity, not kilometer per hour. The SI unit of velocity is meter per second. So you have to convert kilometer per hour into meter per second to find the proper number of velocity. The proper number of velocity will be to change 36 km per hour to meter per second. You have to divide, as we said before, by 3.6. So the result is 10 meter per second. Now we can multiply 10 meter per second by the mass of the object, which is 100 kilogram, to produce the result, which is 1000 kilogram meter per second. Okay, guys, let's solve this problem also. Find the impulse momentum of a car of mass 300 kilogram. Slows down from speed of 30 meter per second to 10 meter per second under a force of 1000 Newton. So he needs the impulse momentum of a car of mass. The mass is 300 kilogram. Slows down from a speed of 30 meter per second, so V initial is 30 meter per second, while the final velocity is 10 meter per second, and this force is provided by 1000 Newton. So how to solve this problem, guys? The rule of momentum, we have two rules of impulse momentum. Impulse momentum F multiplied by delta T, or is the change in momentum P final minus P initial. We don't have the change in time, so this rule is not applicable. But we have the two values of velocity, V initial and V final. So we can say that M V final minus M V initial, which will be M V final minus V initial. M is provided by 300 kilogram, while V final minus V initial is 30 minus 10. So 20 multiplied by 300, it will be 6000 kilogram meter per second. Okay, guys, let's explain the angular momentum. What is the meaning of angular momentum? The word of angular means that the object moves in a circular path. It's another method of measuring the distance, angular distance, or angular displacement, angular velocity, and angular acceleration, as we said before. So, Newton's second law of rotational motion states that the angular velocity of a rotating object, it changes only if the torque is applied to it, as we said before. So, the torque here is equivalent to the force in linear motion. By similarity, we can say that the impulse momentum is equal to F multiplied by delta t, and also it's M V final minus V initial, as we said in the previous example. V final minus V initial is the delta V, so we can write the impulse of angular momentum delta L as a torque multiplied by delta T. Force is equivalent to the torque, or the mass, which is equivalent to the moment of inertia multiplied by delta omega, and delta omega is the angular velocity, change in angular velocity. So the angular momentum of an object is equal to the product of a rotating object's moment of inertia, and angular velocity. Let's solve some questions. Which of the following statements best describes impulse? So the answer is, well done guys, it's the rate of change in momentum. Which two quantities can impulse be calculated as the product of? Well done, it's the mass and velocity. Be careful guys, he didn't ask about the momentum, he asked about the impulse. So the impulse is equal to the force multiplied by time. Well done. Now we are going to talk about the conservation of momentum. Conservation means saving of momentum. So what is the meaning of system, guys? And what are the type of systems? System, guys, mean, if I'm talking about system of collision, that's mean a set of objects that interact with each other during a collision event, including bodies and forces. So we have two types of systems, guys. Or by another way, three types of system, but we are now studying two types, closed system and isolated system, which are reflect back on conservation of momentum. What is the meaning of closed system? A closed system is a system which doesn't gain or lose mass. So the mass during the closed system is conserved. While the isolated system, when the then external force on a closed system is zero, there is no change in mass or energy. There is no change in mass or energy. So the closed system is talking about the mass only, and the isolated system, there is no exchange with the system and the universe, between system and universe. Law of conservation of momentum. It states that the momentum of any closed, isolated system doesn't change. Total momentum before collision is equal to the total momentum after collision. Let's see the following simulation, guys. We have two objects. Object number 1 and object number 2. The object number 1 has a mass of half kilogram, and object number 2 has a mass of 1.5 kilogram. They are going to collide with each other with elasticity 100%. So the system is closed and isolated. The total momentum before collision is half kilogram meter per second and 0.75 kilogram meter per second. So the total momentum is 1.25 kilogram meter per second. Now let's see the collision. The speed of two objects changed. The first one, its speed changed to 1.25, and the second one, its speed decreased to 0.25, but the total momentum by the end almost is the same. So the momentum is conserved. By another way, let's say that the total momentum before collision, which P1 plus P2 before collision, is equal to total momentum after collision, P1 plus P2. Here, before collision, and here after collision. The mass of the two objects, M1 and M2, didn't change before and after collision. M1 and M2. The mass of the two objects didn't change, while the velocity of the first object and second object changed to produce the same total amount of momentum, as the total momentum before and after will remain the same. If we said that the total momentum of the two objects before collision is 2 plus 5, so equals 7, the total momentum after collision will be, for example, 3 plus 4 to represent also 7. The velocity of each of them it changed, but the final and the total momentum is the same. Recoil. What is the meaning of recoil, guys? Recoil refers to the backward motion of an object caused by a reaction. If I'm going to push the wall, I'm going to move back as a reaction force. This is the recoil. If I'm going to shoot a bullet with a gun, so the gun going to recoil back. This is the recoil, guys. For example, consider the skaters below. Assume the start at rest. Experience no external force. Skater C gives skater D a push. Now, both skaters are moving in opposite direction. Skater C going to move backward as a result of pushing skater D. So, it's the recoil, guys. In this case of recoil, the total momentum is equal to 0. Object C moved forward by a certain momentum, and object C, the person C, moved backward by the same momentum with a negative sign. The same value of momentum with a negative sign as it moved in opposite direction. According to the law of conservation of momentum, if two objects collide in an isolated system, so the total momentum before the collision, well done, equal to after collision. Which of the following best describe recoil? Backward movement of an object after it exerts a force. Which of the following is an example of isolated system? A rocket in space, far from gravitational fields. There is no external force acting on the system. Okay guys, what is the meaning of work and what is the meaning of energy? Scan the QR code and return back to me. What is work, guys? Work is the force applied on an object to make it move a certain distance or displacement in its direction or in the direction of applied force. So, if I have an object and a force applied on this object, so the work done is equal to the force applied multiplied by the distance or displacement moved by this object. But if the force applied in a direction which makes an angle theta to the direction of motion, so the rule will be changed into work is equal F multiplied by D cosine theta. A force of 10 Newton is applied to make the object move a distance of 10 Newton in the same direction of applied force. How to solve this problem? He asked for the work. Find the work. Find the work. So, the required part is work, and the force applied is 10 Newton, while the object going to move a distance of 10 meter. So the work is equal to force multiplied by distance, which is 10 multiplied by 10, it will be 100 kilogram meter squared per second squared, or another measuring unit of joule. So the work can be measured by joule, which is main unit, SI unit, or can be measured by kilogram meter squared per second squared. Force has a measuring unit, as we said before, kilogram meter per second squared, multiplied by distance is measured by meter, so the final unit is kilogram meter squared per second squared. So guys, when an object is carried at a constant velocity by a force which acts at a right angle to the motion, there is no work is applied, or there is no work done on the object. Let's simply solve it and know how it works. Work is equal to F d cosine theta. Whatever the value of force is and whatever the value of displacement is, cosine theta, when the force is perpendicular to the direction of motion, it will be cosine 90. Cosine 90, 0. So the value of work will be 0. So the maximum work applied, the maximum work resulted when the force is applied on the same direction of motion. By making a value between the force and the direction of motion, the amount of work done decreases. When it decreases, it will decrease to reach 0 when the force and the direction of motion are perpendicular on each other. When you guys apply a work on an object, so this object going to move and change its velocity. So its kinetic energy will change. This object has an initial kinetic energy and final kinetic energy. The difference between them represent the work done. So we can measure the work done by F multiplied by D, or the final kinetic energy minus initial kinetic energy. Representing the work graphically, we have two types of forces applied on the object, even to be constant force or changing force. Let's study the constant force first. The force has a certain value as time goes and displacement happens. So we are moving the object by constant force. The area under the graph represents the work, as the area under the graph, the area under the slope, represent a square, and the area of the square is equal to width times length. The width is displacement and the length is force. So force multiplied by distance will represent work. By the same way, if the force applied on an object and this force is a changing force, increasing force, it will represent a slope starting from the origin. By increasing the amount of force through a distance moved or displacement moved by the object, the area under the slope will be represented by a triangle. The area of this triangle similarly represents the work. So the work is equal to half times base times height. So the base is displacement and the height is force done. So half force times distance. So the changing force has the half value of the applied constant force. If they are the same, if the maximum force applied on an object is 20 and another object suffers from a constant force of 20, so the resultant work in the case of a changing force from 0 to 20 equal half the value of the applied one, which is equal the maximum value of force applied in the changing force. Let's solve some questions, guys. Work is done when an object is stationary, a force is applied, but the object doesn't move. A force is applied, and the object moves in the direction of the force. The force moves without any applied force. Of course, the force is applied, and the object moves in the direction of the force. What happens to the work done if the angle between the force and displacement is 90? Well done. No work done. What is the energy, guys? Energy is the ability to do work. So the work is the change in energy. As we said before, the work is the change in kinetic energy. Work is equal to final kinetic energy minus initial one. So when you do a work, you change in energy. Let's say simply, you're going to do work. You started this work with amount of energy 100 joules. After doing the work, you consumed from your energy. So the amount of energy exists now in your body less than the start of the duty or the work. So work is equal to the change in kinetic energy. As the work has a unit of joule, also energy has or measured by joule. And so, guys, what is the meaning of power? Power is the rate of change of energy. What is the meaning of power? If you are going to buy a machine, vacuum cleaner, one of them 1000 watt, and the other one has a power of 5000 watt. Which one will do the work faster? Both of them going to do the same work, by the way. Both of them going to clean the same room. But the one which has a higher power going to do the work faster. So we can define the power as the work done by time, or its amount, the change in energy. As we said that the change in work is the energy. Applying the work energy theory to the equation indicates that the power is also the work done divided by the time taken to do this work. The power has a measuring unit of what? What is 1 joule by second. Transferred in 1 second. 1 joule transferred in 1 second. So guys, let's compare between work, energy, and power. Work is measured in joule. Work is equal to force multiplied by density. The change in work, or the ability to do the work, is called energy. And energy is kinetic energy final minus kinetic energy initial, which is the change in work. And also energy is measured in joule. While power is measured in what? Power is the rate of doing energy or work. We have different measuring rules of power. We can say that the power is the change in energy over time, while the change in energy is the force times distance, the work done. So we can say that the power is equal to force multiplied by displacement over time. And distance over time, this term is equal to velocity. So we can also say that the power is the force applied to make an object move with velocity. What is the relationship between work and energy, guys? Work is the transfer of energy. Power is defined as energy used per second. Forms of energy, guys. We have two different or many forms of energy, like electrical energy, like thermal energy, like sound energy, light energy, potential energy, and kinetic energy. Let's know what is the meaning of potential energy, guys. The potential energy is the energy stored in an object as a result of its position. We have two types of potential energy. One of them is called elastic potential energy, and the other one is called gravitational potential energy. So, gravitational potential energy refers back to the gravity, is the energy stored inside the object as its height or elevation increase. As the object moves away from the ground, it gains an energy, which is called gravitational potential energy. Elastic potential energy is the potential energy stored in the spring or a mass attached to the spring. When you stretch this spring like that, so it's going to return back to its original size after leaving it, transferring the potential energy stored in it to kinetic energy. So, elastic potential energy is the potential energy stored in elastic bodies as a result of force done on these objects to make it stretch or compress. Any object under motion has both kinetic energy and potential energy. If the object elevation or height increase, it gains more potential energy, while it loses its speed, so the kinetic energy decreases. While it moving back down, its potential energy decrease, and so its kinetic energy increase. The sum of potential energy and kinetic energy is a constant value of energy called mechanical energy. Mechanical energy is the total energy of an object. Mechanical energy is constant for an object unless an external force is applied on this object to change or make it change in its state, so the mechanical energy change. But as long as there is no applied force, the system is isolated, the mechanical energy is constant, and potential energy plus kinetic energy always have the same value, which is mechanical. As the kinetic energy increase, the potential energy decrease to provide the same mechanical energy. Let's say that mechanical energy has a value of 10, which is represented by 5 plus 5. Potential energy is equal to 5 and kinetic energy is equal to 5. If the potential energy increase to reach 7, so the kinetic energy will decrease to reach 3 to make and provide the same summation, which is 10. And vice versa. If the potential energy decrease to be 2, the kinetic energy must increase to provide the same amount of mechanical energy. For an example, guys, let's study the pendulum. The pendulum is a mass which is attached to a fixed point with a string, and this pendulum oscillates at the both sides of a rest point. The rest point is the initial point which the pendulum starts to oscillate through it. If we pull this pendulum to reach the maximum height, at the maximum height, the potential energy is equal to maximum, has its maximum value. And at the maximum height, there is no kinetic energy. By leaving this pendulum to move down and be dropped, its potential energy decrease as its height decrease and the kinetic energy increase to reach the starting point. At this point, which we call it starting point or rest point or even origin point, the kinetic energy is the maximum while the potential energy is almost zero. After passing the origin point, the rest point, the kinetic energy decreasing as the height of the object increase. So the object or the pendulum gain more potential energy and lose its kinetic energy. The velocity decrease as a result of the attraction of gravity to reach the highest point at the other side. So the potential energy will be maximum and kinetic energy will be zero. Let's do this simulation, guys, and show how the kinetic energy and potential energy change with each other. By putting the skater at the highest point, the skater will have the highest potential energy, and at the lowest point, the skater will have the lowest potential energy and highest kinetic energy. Let's see the motion of the graph and the changing between potential energy and kinetic energy. We can slow the motion and see it. This system, guys, is isolated, so there's no lose in energy. The energy is conserved between potential energy and kinetic energy. The skater will keep reaching the highest point at the two sides, as there is no lose in energy. But if we added the thermal energy, which is resulted from the friction with the surface, I'm going to increase the friction, so the thermal energy is provided. The skater energy is converted, the mechanical energy is converted to thermal energy. By time, the skater will lose its elevation, and the mechanical energy will not be conserved, as there is an external force acted on the system, which is called friction force. So guys, the kinetic energy is the energy of motion. As the speed of the object increases, its kinetic energy increases. As kinetic energy is equal to half mv squared, while potential energy is the energy depends on the position of the object. We have gravitational potential energy and elastic potential energy. The gravitational potential energy is equal to mgh. Mechanical energy is the summation, is the total energy of an object that equal to the sum of potential energy and kinetic energy. So kinetic energy plus potential energy is equal to mechanical energy, and as we said, mechanical energy is constant for the object unless an external force is applied on an object like friction in the simulation which we have also, as we said, gravitational potential energy. The gravitational potential energy is stored due to the gravitational force. Reference level is the position where gravitational potential energy is defined as 0. It's the lowest point, which is equal to the sea level. And we have elastic potential energy, is the energy stored in the object due to the change in its shape, like the pull string. We have also something called rotational kinetic energy. Rotational kinetic energy is the kinetic energy of a rotating body. As we said before, guys, the moment of inertia is similar to the mass in linear motion, and the angular velocity is similar to velocity in linear motion. If we said that the kinetic energy of linear motion is equal to half mv squared, by similarity, the rotational kinetic energy will have I omega squared. So the kinetic energy of linear motion is equal to half mv squared, and the kinetic energy of rotational motion is equal to half I omega squared. Let's solve some questions, guys. Kinetic energy depends on which factors? Both mass and velocity. If an object is stationary, its kinetic energy is, there's no velocity, velocity equals 0, so half mv squared will be equal to 0. What happens to an object gravitational potential energy if its height double. Potential energy is equal to mgh. If the height is double, so the potential energy also is double. Machines, guys. What are machines, guys? A machine is a device that makes tasks easier by changing the magnitude or direction of the force. Guys, machines don't change the energy. Machines don't change the amount of work done. It only changes the direction of force or the magnitude of force. Which is mean the work is conserved during applying the machine. Work before is equal to work after. Work before is F times D. So we can call it F B and D equal to work after, force final, and distance or displacement final. This is the main rule of machine, guys, and the main basic concept of machine. The work is conserved. The work is conserved. How does the machine save effort, and change the force while the work itself is conserved? Let's say that if we have a machine like the seesaw, it's a simple machine. Applying a force here to do the work on the machine to make the seesaw move downward depend on the arm of rotation. So the force multiplied by the distance moved. Here, the force applied by the distance of the arm is equal to the force resulted multiplied by the distance of the arm. This arm is called input arm. And this arm is called output arm. Let's use a lever to move a stone. So here is the stone, and I would like to use a lever, putting another piece of stone here. By moving this stone away from the large one, I increase the output arm, make the resultant force harder. But as the arm of resultant force decrease, that means the resultant force is greater. Let's say by another way. Initial work equal final work. So initial force times, let's say input force multiplied by input distance, which is the arm of input, equal to the output resulted. The work before and after has the same value. Let's say that. By changing the distance, I can manage the force, the input force and the output force. Let's say I will put here a distance, input arm of 10. So I only need 1 Newton to produce a work of 10. While I'm going to increase the length of output arm, resultant. So I will put the arm here by half meter. So the resultant force will be 20. I change the force from 1 to 20 depending on the lengths of an input arm and an output arm. So I saved my effort. I transferred the force. I amplified the force without changing the work done, without changing the value of the work done. All of these guys are the types of machines: lever, inclined plane, wedge, a pulley, wheel and axle, screw. As we said, guys, here is the load and here is the effort. Here is the effort arm, input arm, and here is the resistance arm, resultant or the arm of resultant force. As we said, F1 d1 equal F2 d2, or by another way, we can write input force multiplied by input arm equal to resultant force multiplied by the resultant arm. The mechanical advantage, guys. What is the mechanical advantage? Mechanical advantage is how this machine is useful and can save effort. More effort saved, more advantage of machine. The ideal advantage is when the machine is ideal in its work. There is no loss in work before and after. So the ideal mechanical advantage is equal to the displacement of the effort force divided by the displacement of load force, dE over dr, or by another way, the resultant force, the resistance force multiplied by the effort force, which is the applied force. The mechanical advantage, the ideal mechanical advantage, is always greater than 1, as to make a useful machine, the effort arm must be greater than the resistance arm, or the resultant force, the resistance force, resultant force, is greater than the input force or effort force. An ideal machine transfers all energy, there is no loss in energy, so the output work is equal to the input work. Here is a summary of the ideal mechanical advantage. IMA, ideal mechanical advantage, is dE over dr, distance or the arm of effort, divided by the arm of resistance or resultant, or the force, resultant force, resistance force, divided by the effort force. Which of the following is not a simple machine? Again, guys, we have two different types of machine. One of them is a simple machine, as we said, and another one is a compound machine. What is the compound machine? Is the machine which consists of more than one simple machine, using two pulleys to make a machine. It's a compound machine. So the gear is one of compound machine, not simple machine. What is the purpose of a simple machine? We said to make the work easier by changing the direction or magnitude of force, not by changing the work. The work is constant. Now, guys, we're done with our lesson. Please study well, solve the questions, solve the quiz, and see you in the live session itself.